Welcome back to the channel, everybody. Hope you're all doing well. Maybe you're getting ready for the last Texas 2K at Houston Raceway Park. Maybe you're just getting ready for the season. Maybe you're like me, got a cold, it's snowing, it's cold, so you're going to do some videos or watch some videos. Anyway, what we're going to talk about today, we're going to go back to the do VE numbers really matter? And we're going to touch on a couple of things that I mentioned in that video that I had learned at the time. One was primary fuel density versus temp and its effect on how the VE table could look. And also, when we up fuel flow without changing injector size. So we're going to go back to that Conquest with the 1J. And let's open the software. So once we get the software open, under engine configuration and fuel system, if you remember, there's a tab right here that says primary fuel density. So I've already taken the time to populate this table. We have fuel temp as an axis and we have fuel composition as an axis. If you remember, those were the two presets when we looked at making custom tables for this particular table. Just hit F3 real quick. You can see there fuel composition, fuel temp, they're enabled at this point. So that's where we got those. The numbers I found online for fuel density of gasoline versus temperature and versus ethanol. Ethanol actually came from the Canadian Department of Transportation, as I recall. So they had it down to some fairly low temps. This was worth about 5% in the fuel trims, having that as a populated table. Now, if we go under sensors and we look here, flex fuel composition and temp sensor is obviously selected now. And if you look, you can select fuel temp, flex fuel comp, or flex fuel composition by itself. So the Continental style ethanol analyzers that everybody uses, the GM1, it does both. It has voltage output and it has temp all through the same wire. Haltech can use that natively, so you don't have to do any additional wiring. That all ends up being the same. And you can see this is assigned to SP1 here. But anyway, so getting this table populated did make a difference in fuel trims, which is going to affect how the VE table looks. And then the owner of the car had a single 450, which he decided to use as a lift pump to a radium surge tank, and then had two 450s in that. So we ended up with a lot more flow. We could turn the pressure up, which I did do later to make the injectors act a little bit bigger. But just going and looking at the flow rate, our flow rate numbers got a lot closer. Now, if you remember, these numbers were down like 900. It still needed some to keep the VE table matching because I was doing VE versus cam position rather than VE versus flex fuel. So you have to have a compensation somewhere. I chose to do it here. Now, your methods may vary. You might want to do it somewhere else. One reason I did it versus manifold pressure, which you can see right here, was that at idle and cruise, I need different values than I do at tip in or part throttle, or part load, in this case 14.5 pounds of boost, versus wide open where we were running 32 psi. And we'll look at a data log. But anyway, this is how I chose to do it in order to keep the VE map looking consistent through the poll, or through the map rather. So let's switch to that. We'll go to base fuel tuning. You can see that it's applied some trims, and this is an area that it doesn't really cruise because of how we did the cam timing map, but you can see that it did start to populate up. I should probably interpolate these numbers realistically, but it cruises here at 10 or 15. We can look 10. So the numbers that we're seeing there don't really matter because it's not using that. But now when we move over, we're going to look, we see how as it's spooling, of course, this is 0 degrees of cam advance. We remember that during high advance, I did have to add more fuel, but the numbers look a lot more normal. 87% out the top, 91 at 6,000, still 100 down where it starts to spool. 10 degrees tipping though. Look at what we ended up with. Some really big numbers. 107. So it was actually still just a little bit lean versus that particular cam timing in that section. Switch to 3,000, it's even more. It's 111, 110. So realistically, we still needed to do some work getting, in my opinion, at least getting these VE numbers to look a little more real. But it all worked out. The car did continue to make more power. We got it up to 707 uncorrected. I believe it was 690 corrected, something like that. Let's switch to the data log, and you can see our fuel pressure expected, our fuel pressure really close now as we move through here. Fuel pressure is 85.2, pretty solid. This is probably a sensor setup issue in the map, because what we see at base versus what we see once the regulator is working, because it is a really small aeromotive, it doesn't really bypass enough, we get a little bit of pressure differential. Not necessarily that the car is out of fuel pump or anything like that, but I did also up the base pressure. Up here we have 31.3 pounds of boost. 31 from 84 is 53. So you can see we have a fair amount of boost pressure, or base pressure, excuse me, 7,800 RPM. And then injector duty cycle, 84 or 83.8 at a 12.1 indicated air fuel. So we got a lot of injector duty cycle back. Now, the whole reason that I'm bringing this up was because there were some things that I learned that I wanted to try. This was mainly going to be more the cruise and light throttle stuff, it seemed like. But as I had mentioned, you don't always have the luxury of getting the car on a dyno every time that you change something. So in this case, changing the fuel system, we had to pick and choose where we were going to make the changes. Now, some of these numbers might not be 100% accurate because of the scaling versus boost. So if we look at that, where these numbers right here at 10 to 14 pounds are 10%, 11% higher, it might be that what I should do or could have done is from 7.5 to 14.5 on the flow rate, come in and drop these numbers down. So again, different ways to achieve the same thing. Which one's right, which one's wrong? The answer is yes. We can do it several different ways, and it's just really up to you to make the call, what you like to see and what gives you the best results. I think in this case, what I probably should do is take 10% out here, and then all of a sudden these numbers really start to match. So we'll probably make all these 1050. Next time the car comes back, that's probably what we'll do, is change that and then fix the VE map. But again, what's right, what's wrong? Does it really matter? Probably not. The car's tuned and it makes good power reliably. That's the important part. Anyway, just a quick update. Hope everybody's doing good. We'll talk to you later.